So this is week 8 Friday, and number 1 says how many integers among 1, 2, 3, all the way to 98 can be expressed as the difference of two square numbers. So let's try some stuff first. And let's say the two square numbers are m and n. So m and n are the square numbers. And so we want it to be somewhere from 1 through 98. And so we know the difference of squares is just m squared minus n squared equals to m minus n times m plus n. And so if we set this equal to something, we get, let's say we get m minus n equals something, m plus n equals another something. And if we add these two up, we get 2m equals something plus something. And we already know that this has to be an integer because two integers sum to another integer. So we divide by 2. And we also know that this has to be another. So if we divide by 2, then these two, this has to be an integer because we know m is an integer and m equals that. And so if this is the case, either these two are both odd or they're both even. They can be even or odd. And so all we need is just find two factors in a number 1 through 98 such that both of them are even or both of them are odd. Like say 95. Well, the factors are 1, 1, 5, 19, and 95. And also these two factors, they have to multiply to be a number from 1 to 90. And so if we look at these four, we pair them up and we get these two are a pair and these two are a pair. Let's do them individually. And so in the first two, we have this one is odd and this one is even. And so we already established that this won't work. And so let's test that out. So let's say we have m and this equals to 5 plus 19 because this is what we substitute. Oh shoot, this is not even, this is odd. Sorry. And so this should be right. And so we get m equals 5 plus 19 over 2. And this is an integer. And we get m is 12, but it doesn't matter because we always find another n. And so that works. And let's say 98. Let's say we check 98. And so the factors are 1, 2, 7, 14, 49, and 98. And so we have three pairs of factors now. This one, and this one. Let's try the innermost. This one's odd, this one's even. And that's not supposed to work, but if we input it, 7 plus 14 over 2, we see that this is not an integer. And so we see it doesn't work. And now let's try the next one. 249, it's even, odd. And we try that out and we get m equals to 25.5, which is again not an integer, so it can't be part of this. And we try the last one and we get odd on this side, even on this side. We try that out and we get m is 49.5, which is not an integer. And so we do this for a few more times and we notice that in order for it not to work, it has to have only one factor of 2. Because if it only has one factor of 2, let's say the two factors are x and y, like the pair, then one of these has to have a factor of 2 and the other doesn't. Because x times y equals some number that's called z, and we know z has exactly one factor of 2. And so they can't both have factors of 2, because then that means that it has too much 2's, and they can't have no 2's because then the 2 just disappears. And so if this works, and it does, you can check a few more numbers like 94 or 90, and this works. So we just have to find that many numbers and get 98 minus that. So to find those many numbers, we have to find how many even integers there are. And so that's just 98 over 2 equals to 49. And then how many multiples of 4 there are. Because if they're not multiple of 4, then they're multiple of 2. So we get 49 over 4. And then we round it down. And we get 12. Oh, sorry. 49 over 2, I mean. Because this is even integers, not all of them. And we get 24. And then we subtract these and we get 49 minus 24. 49 minus 24. And we get 25 minus 24. And we get 25. And so that's how many integers there are that are even. And no, that are only even and have exactly one factor of 2. And we just get 98 minus 25, and we get 673. And so that's the answer.